Hi guys, I'm Shahid and good to see you back. I'm back with the Fundamentals of NetWeavers Part 2. In Part 1 we have discussed about what is SAP and basics of SAP, evaluation of BW and topics like NetWeaver, uh, and we have a brief detail about the OLAP and OLTP, the differences between OLAP and OLTP, and data warehousing basics, etc. So now we are going to see the business. We mean business, right? So we are straight into SAP BW and OLAP, and that's what we need. So I request you to pay some attention to ER modeling and star schema. ER modeling is it is not that important, but in order to understand the concept of BW, you need to understand the ER modeling, and it is very helpful. And star schema is what BW is based on, star schema and extended star schema. So I request your attention. So, online analytical processing in BI. OLAP offers business analysts the capability to analyze business process data in terms of the business line involved. Normally, this is done in stages, starting with business terms showing the KPIs, key performance indicators. KPIs means key performance indicators on an aggregate level, and proceeding to business terms on a more detailed level. So every manager needs to find the KPIs for a business, for the scenario. So that's what makes that's what is the job. So you need to find KPIs, you need to analyze them, and you need to know what are they, and what is the right value, etc. So that's what managers do, and our job is to provide required data for them, and in a structured way, so that they can analyze KPIs in different perspectives. They can see according to the department, according to the person, they can see according to the material, according to the material group, which one is working, which one is not working, etc. For example, if you have you generally go to McDonald's, right? When you go to McDonald's and when you see there are offers, you can see some combo offer and something which is running well, and that is what raises the sales of the McDonald's. Why? Because they analyze KPIs from day-to-day basis, what people like. That's where data is working, right? To take high-level decisions. Are you liking? Are these customers liking the chips, or are they liking whole meal, or are they liking the combo, or is that going? Is that a bigger portion for them, etc. Such KPIs and such details are what helps the business, and it drives the business. So in such a way, the questions a multidimensional analysis can answer are, so here SAP BW, we use SAP BW because it provides us a multidimensional analysis, which OLTP doesn't provide much. It is hard to get in OLTP, and it provides us flexibility to drill down and drill across and analyze data in different forms. So that is the use of SAP BW. For example, we have sales, material, time, and KPIs. Right? There is a multidimensional analysis requirement. For example, a business user asks you to show me the sales amount by sales department, by material group, by month. So you have to design a query for that purpose. You have to show the sales amount for certain department and for certain material ID for certain month. You create variables, or you create you have to give the variables, etc., so that while running the query, a user could type the department 1000 or 2000, 3000. He's got the flexibility to see the data according to the department wise, or if he wants to analyze the data according to the material ID, he will type the material ID and he'll view the report. Or if he wants the sales amount according to the month, he can just type the Jan, Feb, March and see the month-wise data, and he can analyze according to that. He can do anything he wants. So our job is to provide the data in a structured way so that it would be analyzed with different forms. The goals of a multidimensional data analysis: to present information to the business analyst in a way that corresponds to his normal understanding of his business. That is, to show the KPIs or facts from the different perspectives that influence them. In other words, to deliver structured information that the business analyst can easily navigate by using any possible combination of business terms to illustrate the behavior of the KPIs. So, to offer the basis for a physical implementation that the software recognizes, thus allowing a program to easily access the data required. So that is the use, to deliver structured information that the business analyst can easily navigate by using any possible combination of business terms to illustrate the behavior of the KPIs is our job as a BI consultant. So data modeling is a process of creation and extending data models, which are visual representations of data and its organization. The objects are displayed in modeling in a tree structure and sorted with respect to hierarchical criteria. The data modeling process helps to model various info providers. These info providers include info objects, data store objects, info cubes, info sets and multi-providers. Effective data modeling results in transforming data into an enterprise information asset that is consistent, comprehensive, and current. So there are different theories on data modeling. There is the conceptual data model, logical data model, the physical data model. The conceptual schema is what we are interested in, because it is helpful to understand the BW or any data warehousing concept. Data modeling concepts are strongly recommended for the projects requiring a standard means of defining and analyzing data within an organization. So data modeling is also a technique for detailing business requirements for a database. Data modeling may be performed during various types of projects in multiple phases of projects. So the one we are interested in is a conceptual schema, conceptual data model, and it is based on ER modeling, and it is really helpful. So ER modeling, conceptual data model describes data from a high level, and it defines the problem rather than the solution from the business point of view. It includes entities and their relationships. So you would be able to find the problem and understand the scenario with the help of ER modeling. And the logical data model describes a logical solution to a data project. It provides more details than the conceptual data model and is nearly ready for the creation of a database. These details include attributes, the individual pieces of information that will be included. So the physical data model, it describes the implementation of data in a physical database. It is the blueprint for the database. So conceptual schemas are used to describe the classes of objects that occur in an application area, their properties, their relationships, and the constraints that hold with respect to those classes of objects. In ER model, it is a detailed logical representation of the data for an organization or business area. It is expressed in terms of entities in the business environment, the relationships among those entities, and the attributes of both the entities and their relationships. The ER model is usually expressed as an ER diagram, a database model that describes the attributes of entities and the relationships among them. So, ER model is a good way of seeing the relevant business objects and their relationships. Depending on the particular circumstances and the extent of personal experience, it will sometimes be sufficient just to draw a diagram showing the entities and their relationships. A simple example of requirement gathering here is a business analyst describes this information, his information needs, and business process as, say, track the performance of materials with respect to customers and salespersons. Here you got the answer in this question itself. You need to find as a BA consultant the entities like in this sentence: materials, customers, and salespersons. As a thumb rule, I'm talking about, as a thumb rule, when user says he wants materials with respect to, he wants to track the materials with respect to customers and sales period, we look for materials, customers, and salespersons. This information, where do we get this information from? That is the question which arises in a BA consultant's mind, and then we put that information in a structured manner, and that's where our job is done. So the following norms related to the business analyst information needs are material, customer, and salesperson. The norms are basic business objects and are usually called strong entities. So ask the business analyst about the relationship between his basic business terms. Normally the relationship between the strong entities are N/M relationships. There is a customer can purchase multiple materials, and a material can be purchased by multiple customers. So you don't actually need to get such information, and for example, if there is such a requirement, you can always ask that. But in this scenario, it is quite clear and quite simple query, and we have to track the materials, customers, and salespersons and present it in a structured manner to the business analyst. But when you analyze for yourself, then you have to look for the relationship between them and ask the business analyst how performance is measured. I mean, this will give you the basic facts. So facts are normally additive and describe N/M relationships. In a business scenario with a working document, this document forms an intersection entity which often resolves the N/M relationships to 1:N relationships. In the first instance, however, it is up to the business analyst whether or not to include the working document in the model when analyzing a sales transaction. So here the intersection entity is a sales order. So a sales order provides all the information of customer, material, and sales department. It is all consolidated, and we create a sales order to create a sales order. So in the next stage, ask the business analyst to be more precise and determine additional details for material, customer, and salesperson. This gives you additional entities and attributes, where attributes are the describing fields of an entity. In ERM diagrams, Attributes show the fields in relational tables. The attributes demonstrate to what extent it is possible to store data concerning this entity. So that is the attributes. Here I want to show you something. We have attributes for everything, but in BW what we do is we have customer master data, material master data, salesperson master data, sales order master data, material group master data, everything, and predefined. It is already given by SAP and we install it through business content. It is provided in business content. And what you have to do is to install the business content and you have to load the data and the thumb rule and the rule is to load master data first and then the transaction data. If you don't load the master data and you load the transaction data, then the fields for all these phone number, city, customer name, customer ID will be empty for a customer. So you have to decide for yourself. If you need the data, you have to load them. You have to create a master data first and load them, keep it in the system and provide a transaction data, and SAP BI system will give the drill down and drill across functionalities for them. So a person can see the attributes in a current form and in a historic form as well. So to enable such functionalities of BI, you have to load the master data first. It is useful for the following steps to ask the business analyst for details concerning relationships between entities and relationships between entities and their attributes. Because sometimes entity and attribute can have abnormal relationship like N:2M. For example, here there is a material and color. These relationships have to be treated carefully. We have color and a material, and there are N:2M relationship between them, because it can be N materials but it can be N colors as well. So a material 1 can have 4 colors. It can come in 3 different colors or 4 different colors, and you have to choose in between them. So you have to provide all the information, which color is. Sometimes user might want to know which color is going better. For example, there are cars, and manager, he might want to know the different colors of cars which are going well, and they generally, according to that, they take decisions either to provide gold color. For example, if they want the gold color car and with the black interior, if they find it good and if customers are liking it, black and gold is always the favorite color, my favorite color. I don't know about the others. So it always works well. So maybe they like to produce black interiors with the golden color cars more in future, so that like that decisions can be taken according to the analysis. That's why we do analysis. Common data models used for modeling the data warehouse. Transactional structures. Transactional structures are used to store data from an OLTP system in a relational database. Above all, these structures are required to store data on an atomic level to avoid redundancies and for faster access to individual transaction data. So these are the transactional structures. In a transactional data model, a query on revenue from a company over the last 2 years would require reading all transactions. So if you go to OLTP system, this is how it will be accessed, and it is time consuming. That is why we need BI, and it is a burden on the system, time consuming, and such a busy system should be relieved from the reporting. So it is always suggestible to have the warehousing tool for reporting purpose. So apart from performance problem, the disadvantages of transactional structures is that they only support the current view of attributes. You can get the historic view of attributes. You have to load the data to the OLAP system to get the historical view. Flat structures are the archetype of OLAP specific data models. They represent a first step to separate analytical data from operational data, and thus offer the option to store data in an aggregated form so that for analysis purposes, depending on the aggregation level, a strongly minimized database can be used. While transactional structures are normalized, flat structures are denormalized on purpose to map the database on a higher aggregation level and in a simpler form. From an analytical perspective, this is an important improvement compared to transactional structures. However, because of some disadvantages, they are usually no longer used as a database for OLAP application. In BW, flat structures are used in any area responsible for data exchange, extraction of data from source systems, and staging. Since this form of data exchange is the easiest and best performing. So a flat analysis table is typically like this: customer number, material number, date, sales organization, postal code, quantity, etc. And in BW, there's example for flat structure is DSOs. We keep DSOs in the middle of data flow because we need to maintain PSAs every fortnight or every month, and in order to maintain them, we need to delete the data. So SAP recommends to keep right optimized DSOs so that we can have the complete snapshot of data in an object, like right optimized DSO. Even though if we want, if the data gets deleted from the info provider, from the target, you will still have the snapshot of data in DSOs. So it is recommendable. Disadvantages of flat structures: all characteristics have to be stored as table keys, and this causes very long keys. The number of table fields is limited by the database system, so not all requirements might be fulfilled. Flat structures enable only the historic view of attributes, and when changes to the data model are made, much effort is required to rebuild the complete table. Any structure, even the star and the Snowflake schema, needs to contain one of the data models which is described below. So that was flat structures, and now for the basic design of the data model, any structure would need one of this model to use one of this model. So either it is a key figure model or account model. In key figure model, the key figure is a field provided for each key figure in the structure of the flat table. Therefore, in the data record all key figures that are related to the key combination of the flat table are stored in the data record. As a prerequisite for the use of the key figure model, the structure of the respective key figure for each data record must be basically identical. If from a large amount of key figures in each data record only a few are filled, the usage or storage is inefficient and will lead to an unnecessary high resource waste. So how does it happen? Here's the key figure model. You have key figures, individual key figures as fields. So this gives priority to the key figure model rather than further space. So you have different key figures. If the key figure value is present, it will show the value. If not, it will show the blank space. And in account model, you have a semantics and key figures. In a semantics, it takes the key figures, different key figures. For material 4711, for a month we have 3 key figures: sales, price and discount, and then the value of the key figures are there, which we have seen in key figure model in differently. So it only needs 2 fields for account model to show the 3 key figures. It can be 3 or it can be 30. So these are 2 different perspectives, and if you go for the account model, it takes a lot of records. If you go for the key figure model, it takes a lot of fields. That's the difference. The account model provides only 1 key figure per unit and anchors the semantics of the respective key figure in a key field of the table. Thus, a data record of the key figure model that describes 4 key figures would result in 4 data records in the account model. Compared with the key figure model, the account model produces multiple data records, but it scores in terms of flexibility and optimal use of the defined data structure. In practice, the account model is suitable for controlling purposes where a business can be evaluated from a multitude of different key figures that may hardly be used in other businesses. So we are into the important topics, star schema and extended star schema. So star schema, it consists of a central fact table and dimensions surrounded or relationally linked dimension tables. So this is the typical star schema, and it consists of a central fact table and the dimensions surrounded. And so you can see that in a fact table, key figures are provided. Fact table consists of key figures and the dimension IDs, and which dimension IDs which link dimension to the fact table, and the dimension ID is a primary key for the dimension. For material dimension, a dimension ID is a primary key, and for fact table, a dimension ID of material dimension is a foreign key. And I guess you are familiar with the primary key and foreign key. There is nothing you have to, a unique identifier in the material dimension is a primary key. A unique identifier is a primary key, and dim ID in material dimension is a primary key. And in fact table, it is already used in dim ID, dimension material. So the dimension ID in fact table refers as foreign key, which is already used in material dimension. So it is called foreign key, as the name suggests. And the same goes to other dimensions, and all the dimension IDs are stored in fact table, and the key figures are stored. And as you come for the design of dimensions, the dimension, we design dimensions according to the 1:n relationships. For example, material ID is there, and it has got the related fields like material type, material name, price, color, and customer ID is there. The related fields like customer name, city, phone number, address, etc. Everything is mapped and sorted into the dimensions, different dimensions. So that is how we design star schema, and it represents a star. So it is named as star schema. So it supports historicity of attributes, and the relational link between fact table and dimension table is made with the surrogate keys, which are 4 bytes long. Okay. And the multi-dimensional model, where facts are based in the center with dimensions surrounding them, is a simple but effective concept which is easily recognized by technical resources as well as by the business analysts. The central intersection entity, sales order, defines a fact table. Attributes which forms 1:n relationship should be stored in the same dimension, that is customer and customer name, city, etc. Primary key of dimension table becomes foreign key of fact table. And as there is no correspondence to time in ER model, time attributes has to be introduced in multi-dimensional model to cover the analysis needs. So that is the concept of star schema. Dimension tables are demoralized like flat structures, and they are built in consideration of technical aspects. So here we come to the Snowflake schema. It is an enhancement of star schema with master data tables. Here, it is an enhancement of star schema with master data table. We got the same star schema up to now, right? But there is a master data table. What is it? How does it work? Here, this phone number here is a historic attribute for the customer dimension at present. And here, this same phone number for the customer ID is a current attribute because we are using it in master data in the query, and we can see that in drill down. So that's the function, that's the difference, and that's what BW provides. And that's the one thing that BW provides. So let's see. It allows for the attributes to display not only historically but also currently. Attributes can be stored not only in dimensions but also in master data tables that are relationally linked to characteristics in the dimensions. When I say about loading master data first and then the transaction data, the theoretical way of that sentence is this: the attributes can be stored not only in dimensions but also in master data tables. So that are relationally linked to characteristics in the dimensions. So it allows it allows attributes to display not only historically but also currently. How does it allow current analysis? By storing the master data. So a fact table is connected to the dimension tables through dim IDs, just as star schema, and dimension tables are connected to the master data tables through SIDs. When you load the master data, SIDs are connected, and those SIDs are connected with the dimension IDs. So that's how you will be able to analyze. Unlike in normal star schema, true characteristic value will no longer be found in dimension tables, but in attached SID tables of the info objects. Unlike in normal star schema, true characteristic value will no longer be found in dimension tables, but in attached SID tables of the info objects. So you can see that phone number here, this is the example. Phone number in customer dimension is a historic attribute, and phone number in customer ID master data is a current attribute. We are looking at star schema and Snowflake schema. So the performance according to the star schema and the Snowflake schema is very good. Complexity is medium for the star schema and very high complexity for the Snowflake schema. Historicity is present in all of this except for transactional data models. And current view, current analysis is present for Snowflake schema and for transactional data model. So it is not present for flat structures, flat analysis and star schema. So again, the conclusion is BW is based on star schema and extended star schema, and it provides both historic display and current display of the attributes. Okay, and this is the end of the basics, and we will look into the data flows straight away, and how to I will show you, run you through the document for the data flows and how to create the data flows, and what actually is the process to create data flows. And after looking at those documents, you will be able to understand the data flows and how does the data runs for master data loading and transactional data loading and generic extraction, etc. So I will see you then. Until then, goodbye, guys.